Good morning, class. The session is being recorded. We are looking at the exam review number 3, which covers section 3.5, part 2, implicit differentiation and related grades, all the way to section 4.2. First, a lot of differentiation formulas that we have discussed. It is important to be able to handle the differentiation, not just for the sake of this exam, also for the reverse process coming up known as anti-differentiation or integration. Logarithmic properties are extremely important. So let's quickly recap what we need to know here. It is important to look at the definition and understand that log is simply an exponent. The base must be positive and it can't be 1. And we have the general definition. So what I want to go over the properties. I want to recap for you, and we want to understand what that means. This is a general case where the base is any arbitrary number, such as A or B or C, or you name it. For example, if we choose B, what happens? Log 1, regardless of the base, is 0. Log base B of B equals 1. I want to make sure we understand those as we look at the general case. One and 2. As we look at the specific case for natural log base E, common log base 10. So what you need to understand is the following. Log of 1 with any base being a general base B, base being a natural log, that means E, or common log, that means 10, it gives you 0. If the base and the argument are identical, the answer is 1. When we write ln E, remember the base is E. When we write log 10, the base is 10. So if the base and the arguments are the same, the answer is 1. Numbers 3 and 4 refer to the fact that logarithmic functions and exponential functions are inverse functions. So log base B of B to the power of X, or B to the power of log base B of X equals to X. Take a look at specific case base E, or natural log, specific case base 10, or common log. That works the same way. This is the product rule. Number 5 is the product rule. General case, natural log, common log. Number 6, quotient rule. Number 7, the power rule. So as you can see, all of them refer to the same thing. The general rule, you should be able to come up with the specific case, natural log or common log. Then, of course, we have change of base formula. Log x base b is the same as log x over log b with any base A. But in particular, we either use common log or natural log. And then it gives rise to the derivative function. The derivative of ln x is 1 over x. The derivative of ln of g of x, you flip it over times g prime, okay? All right, let's look at a couple of examples, starting with implicit differentiation. Remember, the idea behind implicit differentiation is that we solve just the way it is. We don't have to solve for y. So let's differentiate implicitly as follows. 2x plus y to the power of 4 is x minus 2y. Okay. We want to get the first step. Number 4, the exponent sits in front, becomes the coefficient. We write the parentheses to the power of 4, becomes 4 minus 1, so power of 3. And then by the chain rule, the derivative of the parentheses, you're going to differentiate 2x plus y, which results in 2 plus, now the derivative of y is either y prime or dy dx. Remember, y is the same as, in essence, g of x. So the derivative of y is y prime equals g prime of x. That's the idea. So let's quickly recap. 4 sits in front, then 2x plus y to the power of 4 minus 1. The exponent goes down by 1. By the chain rule times the derivative of the parentheses, which is 2 plus y prime. The right side, x gives you 1 minus 2, y gives you y prime. As long as we have this step, practically we are done, because this is the only calculus step. Now to solve for y prime or dy dx, we use our algebraic techniques. We can multiply this by 2, okay? So let me just do this so everybody understands what we're. So if you look at this case, the reason I'm doing it this way for the sake of solving for y prime, making life easy. So when you multiply 2 by that, it becomes 8 times the parentheses to the power of 3. And then you multiply y prime by it. So take a look at how we write that. Okay. Now, we are going to move things around, which means this is going to move to the right, becomes negative. This is going to move to the left, becomes positive to y prime. Why are we moving it in this fashion? Because we want to bring everything involving y prime to the same side. Everything involving y prime to the same side. This is on the left, let it be. We move the negative to y prime to the left also, becomes positive to y prime, and this moves to the right. So let's write it. Now, remember what we are doing. We are solving for y prime. So on the left side, we can factor out the y prime as follows. If I take the y prime out, what is left? The piece in blue from the first term, and the last one only 2. The right side remains intact. All you have to do, divide both sides by these brackets, and that's your final answer. dy dx or y prime is 1 minus 8 times 2x plus y quantity cubed over 4 times 2x plus y quantity cubed plus 2. Okay. We want to differentiate this expression sine y plus 2x cubed y squared equals 6. First, I can put a raised dot in between so we understand we need to use it. product rule on that piece when we get there. So let's look at sine y. Remember what I told you, when you want to differentiate sinusoidal functions, the way you read them makes a difference. So you want to read and pause. So I'm going to read this as sine and I'm going to pause, sine. So the derivative is cosine. So cosine y, you need an argument for that. The derivative of sine becomes cosine. And remember, this is not x, this is a function of x, therefore times y prime or dy dx, because y is like g of x, by the chain rule times y prime or dy dx. Product rule, 2x cubed gives you 6x squared times y squared plus y squared. Let me actually do it in this fashion so we understand. So we are looking at 2x cubed times y squared. 6x squared times y squared and plus y squared gives you 2y, y prime or dy dx times 2x cubed. The right side is a number. Any number results in 0. So we have this one, it's fine, okay? This one is fine, 6x squared, y squared. And these two, we write them as 4x cubed y dy dx. All we have to do, everything involving dy dx we keep. So we're going to keep these two. And factor out the dy dx, which gives us dy dx times cosine y plus 4x cubed y, and move positive 6x squared y squared to the right becomes negative. Divide both sides by the parentheses, and you're done. As always, when you have a fractional expression, you want to see if there's any way you can simplify it. If you can, you must. If you cannot, you're done. Implicit differentiation. We want to find an equation of a tangent line to x squared plus 2xy minus y squared plus x equals 2 at the given point 1, 2. So the first question in this page, we want to find the equation of a tangent line, which means we need two things, everybody. We need a pair x comma y, which is given as 1, 2. We also need the slope. In order to find the slope, first we have to differentiate, and then we have to plug in. So first, differentiate implicitly. Let us differentiate implicitly. All right. X squared 2x plus 2xy. Again, let me put a raised dot in between, which means we are multiplying 2x by y. So 2x gives us 2 times y, plus y gives us y prime or dy dx times 2x, minus y squared gives us 2y, y prime, x gives us 1, any number gives us 0. A quick recap, x squared gives us 2x, 2x gives us 2 times y gives us y prime times 2x, minus 2y, y prime, plus x gives us plus 1, and the right side is a number resulting in 0. You can plug in the pair and find the y prime just the way it is. You can do that. But let's solve for y prime, which means you are going to keep these two, okay? And you're going to move the 2x, 2y, and 1. And all of them take a negative sign on the other side. So one more time. We keep this and we move everything else. On the left side, we can factor out the y prime. By the way, you can factor out 2y prime. I want you to know that. Okay. But we are interested in solving for y prime. So if you factor out the y prime, all you have to do divide by 2x minus 2y. The reason factoring the 2 doesn't really make much of a difference. If we had, this would become 2 times x minus y, and that's great. But if you plug in, if you try to simplify, nothing simplifies, so it makes no difference. Now, the next step is to plug in to find this slope. So what do we get if we plug in, class? Let's plug in. Replace the x with 1. Replace the y with 2. And I hope you realize if you plug in, this gives you minus 7 in the numerator, minus 2 in the denominator. So the slope is positive 7/2. It's important to see how we arrive at positive 7/2 because the top and the bottom both are negative. So y minus y1 that means y minus 2 equals m, that means 7/2, times x minus x of 1, that means x minus 1. Simplification, all you have to do, write down y minus 2 is 7/2 x minus 7/2 negative 2 moves to the right side, becomes positive 2 or positive 4/2, and they add up to give us negative 3/2. So y is 7/2 x minus 3/2. By the way, you can always check your work, and it's really a good practice to plug in 1, 2 to make sure we have it right. Always check your work. So an implicit differentiation results in y prime or dy dx. Plugging in gives us the slope. We have a pair, x comma y. We have the slope. We come up with the answer. The next question, we want to find dy dt. So you really want to pay attention to this before even you move on. The moment you see dy dt, what does it tell you? It tells you your independent variable is t, everyone. Which means the derivative of y or y prime is really dy dt, not dy dx. And the derivative of x is no longer 1, it's dx dt. So before even you read on, just look at the first one. Because it's asking for dy dt, it is also telling you your independent variable is t. As long as we pay attention to that, the rest becomes simple. So we want to find dy dt for the given equation where dx dt is given, x is given, and y is given. Okay, everyone? So with that being the case, we can put a raised dot between x and e to the power of y. Therefore, we use the product. So the derivative of x, again, remember I said it's no longer 1, it's dx dt. So dx dt times e to the power of y. And then the derivative of e to the power of y, exponential is always itself, e to the power of y And by the chain rule, the derivative of y is dy dt. And by the product rule times x. 4x gives you 4dx dt. Y cubed gives you 3y squared dy dt. So this is it. You're done with calculus. The rest becomes elementary algebra. Let's plug in. Replace the dx dt with 2. Y with 0. Same thing here. Dy dt, we don't have it. Just keep it. X, replace it with -1. Continue on. And the missing dy dt will be found. Although you can solve for dy dt, but it's really not a good practice for a question like this. It's a little bit more complicated. So having said that, let's plug in everybody. So dx dt, it's 2. E to the power of y, which is 0, plus e to the power of y, which is 0. Dy dt, we don't have it. And x is replaced with -1. Plus 4 times dx dt, which is 2. And the right side, 3 times 0 squared dy dt. This whole thing, because y is 0, goes to 0. In other words, here's what you have, everybody. First of all, this is 0. Very straightforward. E to the power of 0, I hope you know it's 1. Okay. So what you have here is a 2 plus, now e to the power of 0 is 1. 1 times dy dt times -1. So negative, so minus dy dt plus 4 times 2 is 8, and the right side is 0. Okay. So I hope you realize dy dt becomes 2 plus 8 or 10. And that's your final answer, everybody. That's your final answer. Let's go to the next question. We are differentiating these questions involving a natural log. So this is 2x times ln of 3x squared. Class, notice ln of 3x squared we can simplify. However, it doesn't make that much of a difference. In fact, it could make the the process a little bit more involved. So it is the product of 2x and a natural log. So you are using the product rule. Let's do that, everybody. So 2x gives you 2 times ln of 3x squared. But what about ln of 3x squared? We are going to use ln of g of x. How do you differentiate that? Flip it over 1 over 3x squared. Okay, 1 over g of x, 1 over 3x squared, times g prime of x times the derivative of 3x squared, which is 6x. And because of the product rule, times 2x. So let's quickly recap. 2x gives you 2 times the second piece. The second piece, you flip it over the argument, 3x squared, 1 over 3x squared, times the derivative of 3x squared, which is 6x, times 2x by the product. So the first piece doesn't change. But what happens to the second piece, it can simplify into 12x squared over 3x squared, which is simply a 4. And you're done. We did this question, number 6, natural log can be simplified into natural log of the top minus natural log of the bottom, and then natural log of the top, ln 5x is ln 5 plus ln x. So the top gives us ln 5 plus ln x minus ln of x squared plus 5. It's a combination of a product and quotient rule when it comes to logarithmic functions. This is algebra. Now the next step is differentiation, and it's calculus one by one. Ln 5 gives you 0. Ln x gives you 1 over x. Minus ln of x squared plus 5. Flip this over. 1 over x squared plus 5 times g prime of x times the derivative of x squared plus 5, which is simply 2x. That's what we get. We take a common denominator of x times x squared plus 5. So we have 1 times x squared plus 5 minus 2x times x. The numerator simplifies to negative x squared plus 5, everybody. Here's the next one. We want to differentiate this log. Remember, the first step is to use our algebraic techniques to simplify if we can. Power rule indicates that we can bring number 4 in front. Power rule of logarithmic properties. Now we are going to differentiate. How do we do that? First, we're going to use the steps that we have here, and then I'm reminding you what is missing here. So 4 times. You are going to go with this function g of x and flip it over 1 over 9 minus x cubed, 1 over g of x. Then you need g prime of x, the derivative of the inside, negative 3x squared. Because the base is not e, see this is ln, but this is log, because the base is different, divide by natural log of the base. The base is missing, that means common log, that means the base is 10, divided by ln 10. And all you have to do is just rewrite this. There's really not much you can do. The numerator contains 4, 1, negative 3x squared, 1. Their product is negative 12x squared. So we can write it in this fashion: 4, 1, negative 3x squared, 1. Those are the ones in the numerator, okay, class? Their product is negative 12x squared. And then denominator is 9 minus x cubed times ln 10. The reason we put the 9 minus x cubed first, because if we put it after ln 10, one may think it's part of the argument of natural log. We don't want that. Let's look at the last question I want to do for today. We are given the function y equals f of x equals x squared over x minus 8. We are asked to come up with dy and delta y at x equals 4, dx equals 0.2. Needless to say, dx and delta x are the same. To do that, remember f prime of x is dy dx, and then dy is f prime of x dx. The very first step is just differentiate using the quotient rule. So I'm going to write this as f over g, the derivative of a quotient rule f prime g minus g prime f over g squared, means the derivative of the top, which is 2x times the bottom, minus g prime, the derivative of the bottom is simply 1 times the top, which is x squared, and just write the bottom in a parentheses and square it. So there's not much you have to do for the denominator. Simplification of a numerator requires now some algebraic techniques. Simple 2x squared minus 16x minus x squared. We can combine these two. This is it. And we notice dy is the same thing, just times dx. We are going to write, therefore, dy is the same thing times dx. To evaluate this, replace the x with 4, dx with 0.2. We are going to do that. (16) minus 64 over 16. 16 minus 64 is negative 48 divided by 16 is negative 3 times 0.2 is negative 0.6. This whole thing, class, equals negative 3. If you multiply by 0.2, results in negative 0.6. What about delta y? By definition is f of x plus delta x. So f of x plus delta x, that f of 4.2, minus f of x minus f of 4. That's it. Elementary algebra, meaning replace the x with 4.2 first, evaluate it, then replace it with 4, evaluate it. I'm going to assume everybody can evaluate those using a calculator. We end up with negative 0.6421. What I'd like you to do is to compare the two numbers. Look at this number versus this number. Negative 0.6 versus negative 0.6421. They are extremely close. Why is that? Look at the value of the x. Compared to x is fairly small. The x or delta x is only 0.2 compared to 4. So they are fairly close, those two values. And that's the idea behind comparison of dy and delta y. They are not identical, but when delta x is small, they are extremely close.